Lab. What is the relationship between sediment size, settling rate, relationship between sediment shape and settling rate, and relationship between sediment density and settling rate? To do this, we're going to drop different sized beads through a column of water. So here's a column of water from this point here to this point here is 50 centimeters. And we're going to time how long it takes different sized beads, different shaped beads, and different density beads to settle through that column of water. So now we're switching from talking about erosion to talking about deposition. Shape and density affect the deposition rate of sediment. There are going to be 3 beads, a 4 millimeter bead, 7 millimeter bead, and 12 millimeter bead. Which one do you think will settle at the fastest rate? So we're focused on size. Of the 12, 7, and 4, the large, medium, and small size beads, which one do you think will settle at the fastest rate? Put your answer under the hypothesis. We're also going to have different shaped beads, not just size, but different shape. Notice that these beads have the same density. They have the same size. They're both the same 12 millimeter bead. They were just, one of them was flattened out. Which of these do you think will settle at the fastest rate? The round or the flat? Put your hypothesis as your second line in your hypothesis in the lab. And then finally, the third line is which density bead. So there's 2 beads with the same shape and the same size. One has a density of 1.3 centimeters. The other has a density of 2.5. Right, one has a density of 1.3 grams per cubic centimeter. One has a density of 2.5 grams per cubic centimeter. Which bead do you think is going to settle through the water at the fastest rate? Again, that goes into your hypothesis. I'm going to do the procedure for you right now. So it says measure the time it takes the beads of various size, shapes, and densities to settle through the water at a distance of 50 centimeters. We're going to do a couple trials of each. Let's start with our 4 millimeter beads. Here's the first trial for our 4 millimeter beads. You time, using your stopwatch or Chromebook, how long it takes the bead to go from here to here. It's a small bead. I'll point to it as it goes down. There. To there. How much time did that take? Put that in the first trial in your lab. Here's the second trial. Again, you're timing it from here to here. That's 50 centimeters. This is where you start. This is where you stop. Here's the third trial. So now that you have 3 trials, you're then going to calculate the average. So the average is adding these 3 numbers together and then dividing by 3. So add them together, divide by 3, that gives you the average. Let's move on to the 7 millimeter bead. Here's your first trial for the 7 millimeter bead. And stop. Second trial, 7 millimeter bead. And stop. Enter that into your deposition chart. Third trial, 7 millimeter bead. So now you should have data for 7 millimeter beads. You have 3 trials. add them together, divide by 3 to get your average time. Let's move on to the large beads, which are 12 millimeters in size. First trial. Here comes the second trial. And third trial. And again, add those 3 numbers together, divide by 3 to get your average time. The class averages, I'll show you in a little bit. Now it's time to change the shape of the beads. For the rounds, those are exactly the same shape, size, and density as these 12 millimeter beads. So whatever numbers you have here can just be copied and pasted here. We already know how fast the 12 millimeter round beads fall. But what about the 12 millimeter flat beads? We'll need to do those. Here's your first 12 millimeter flat bead. Guess it's not a bead. Start. Stop. Second trial. Got an air bubble on there. I'll knock that off. There you go. Start. Stop. And finally, our third trial. Start. Stop. So there are your rounds. Remember, we got our round data from the 12 millimeter rounds that we started when we did bead size. You just timed your flats, your 3 flats, calculate the average of those 3. And let's move on to density. The 1.3 grams per cubic centimeter, the density of these was already done when we did the round beads. These round beads were 12 millimeters, 1.3 grams per cubic centimeter. So whatever information you have copied here for the 12 millimeter beads, which is the same as here for the round beads, will be the same that's here as for the 1.3 density beads. So the only thing we need to do is to time the 2.3 density beads. These are a little on the fast side, so please be ready with your start and stop times. First bead. Second trial. Third trial. If you need to, you might need to go back and replay those to time those better. So now we have all of our data charts filled out except for the class average for the density, the shape, and the size. In class, we had students put their averages on this data sheet. We still have some groups left to go, but we can use this data to find out what the class average is. Instead of adding all of these up and dividing by how many there are, spreadsheets allow you to enter a calculation. So I'm going to type in equals average, you can see it already populating all of this range from B4 all the way down to B28. So I'm going to type B4, B28, and it calculates the average for me. So the average time was 4 millimeters. For the 4 millimeter sized beads was 12.2 seconds. I don't have to do that again for the other columns. I could simply click my 1. Now this in this cell is not 12.2. In this cell is the average of B4 to B28. If I grab the small little blue square and drag it across, the sheet will automatically calculate each of those columns for the same thing. So there are the class averages. You can put those class averages now into your lab. To get those class averages, either the current ones or the ones that when you're doing it, again, you just click this link. It will open up the Deposition of Beads Lab data, and down at the bottom we have our class averages. The only thing you have left to do is to write your conclusion, where you answer your purpose, tell whether your hypothesis was correct or not for each characteristic, both size, shape, and density. Give specific data. Don't just say a certain size, shape, or density was faster. Give specific data. Give the times to prove that it was faster. And then talk about what happens when a river carrying sediment of different sizes enters a lake. Talk about which particles will be deposited first and which ones last.